I welcome you to the third session of geometry. In this session, we will continue with some more properties of triangles. We may not solve many problems in this particular session, but we will look at some more important and yet basic properties of triangles. Let us look at the first one. This is known as the basic proportionality theorem. You see, we have ABC, which is a triangle, and in the triangle DE, this line DE is parallel to BC. So if DE is parallel to BC, then basic proportionality theorem tells us two things. Number one, AD upon AC is equal to AE upon AB. This is the first result. So you have AD upon AC, which is equal to AE upon AB. And as a corollary of this particular result, we also have AD upon DC is equal to AE upon EB. Let us solve a very simple problem based on this property. In triangle ABC, DE is parallel to the base BC. Find the value of x. Now you can notice that 2x, x plus 1.5, these are all values of lengths of AD, AE and EC, etc. And you are given DE parallel to BC. So we can apply the basic proportionality theorem in the following way. AD upon AB is equal to AE upon AC. All we need to do now is substitute the values of AD, AB, AE and AC from the given figure. So AD is equal to 2x divided by AB, that is equal to 2x plus 8, is equal to AE, that is x, divided by AC, which is x plus 1.5. On simplifying this equation, we have 4x square plus 3x is equal to 2x square plus 8x. And on solving this equation for x, we get the value of x as 5 by 2. So we saw how we can use basic proportionality to solve questions like these. Now let us take a look at some more properties of triangles. This is the midpoint theorem. Suppose we are told that D and E are midpoints of the sides AC and AB in the triangle ABC. So D and E are midpoints given to you. Then there are two outcomes. DE must be parallel to BC by default, and the value of DE must be half of the length of BC. So these are two important results which are collectively known as midpoint theorem. Next, as a byproduct of this midpoint theorem, if we have a triangle ABC and DEF are midpoints of the sides AC, AB and BC, then we have the following outcomes. The triangle gets divided into four congruent triangles. So these triangles ADE, DCF, DEF, FEB are all congruent triangles. Congruent means they are equal to one another. And therefore, the area of each of these congruent triangles, that is area of ADE, must be equal to area of DEF, must be equal to area of DCF, must be equal to area of FEB, which is equal to 1/4 the area of ABC. So this result is nothing but an outcome of the midpoint theorem only. Let us look at another property. Two triangles between the same two parallel lines, let's say L and M are parallel lines, and we have triangles ABC and DBC. You would notice that both these triangles are lying on the same base, that is BC, and between the same two parallel lines L and M. So if two triangles lie between the same two parallel lines and on the same base, their areas must be equal. So by the property, area of triangle ABC must be equal to area of triangle DBC. Let us look at another property, and this is a property of similar triangles. First of all, what are similar triangles? If ABC and XYZ are two triangles such that the angles of ABC are all equal to the angles of XYZ in that order, then we say ABC is similar to triangle XYZ. Now remember, universally this is an accepted convention that if triangle ABC is similar to triangle XYZ, we also imply that angle A must be equal to angle X, angle B must be equal to angle Y, and angle C must be equal to angle Z. So this is a universally adopted convention and you should follow it unless it is stated in the question otherwise. So if three angles of triangle ABC and triangle XYZ are equal, then we have angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z, as I already told you. Sides opposite equal angles are corresponding sides, and the ratio of corresponding sides is equal. This is the basic principle of similar triangles. That is, the sides opposite equal angles are corresponding. So, if angle A and angle X are equal, then the side opposite angle A is BC and the side opposite angle X is YZ. These two sides are corresponding sides. And mind you, the ratio of all corresponding sides in similar triangles must be equal. So ratio of AB upon XY, which is one set of corresponding sides, must be equal to AC upon XZ. These are two other set of corresponding sides. And this must be equal to BC upon YZ. And this ratio we call as R. And this is also equal to the ratio of perimeter of ABC upon the perimeter of XYZ. Now, when we solve questions on similar triangles, we've got to be very careful about the corresponding sides. Mind you, we cannot take any random ratios. We have to take the ratio of corresponding sides when we are solving questions related to similar triangles. Let us look at another property. In case of similar triangles where ABC is similar to XYZ and three angles of triangle ABC are equal to three angles of triangle XYZ, and A angle is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. A moment back we saw that ratio of corresponding sides and corresponding perimeters is equal. Now, what about the ratio of corresponding areas? Because area is expressed as a product of two sides, therefore, area of triangle ABC upon area of triangle XYZ is equal to the square of the common ratio, that is R square. So with this we come to an end of this particular session on properties of triangles. If you have any query or any feedback, feel free to contact us on studentservices@pfindia.com. Some of the other sessions will contain application of these theories. Thank you.